I'll start the webinar as well.
Okay. Just going to give a few moments for folks to trickle in. Good morning, everybody. All right, I'm going to get started here. I think we've reached quorum. All right, good morning, everybody. I'm welcoming all of our panelists. Feel free to turn your cameras on now. Thank you, everybody, for joining our webinar today, where we're going to be talking about carbon removal philanthropy and focusing on Aquarry's work turning toxic mines into safe carbon sinks. My name is Sophie Westover. I'm head of climate at REN. REN is a public benefit corporation that makes it easy for businesses and individuals to act on the climate crisis. A few years ago, myself and one of our co-founders, Ben, decided, in addition to our core product, which is helping to essentially help folks offset their emissions, that we wanted to find a more direct way to catalyze climate action. So we started the REN Climate Collective, which is a fiscally sponsored nonprofit with the goal of accelerating carbon dioxide removal innovation. This year, to select our CDR grantee, we ran a request for proposals, and the number of applicants was really staggering. We got over 240 applicants, which I think just demonstrates the need for philanthropic funding in this space generally. To kind of sort through those applicants and figure out which one we thought would be the best fit for the Red Climate Collective, we implemented a scoring framework with the help of an intern, where we looked at how novel the CDR pathway was. We were looking for a project that had a relatively low technological readiness level and had less market traction than, say, some of the more advanced pathways like biochar. We wanted to look at how expansive co-benefits were, if there was a clear pathway to develop or use a credible monitoring, reporting, and verification framework, also called MRV. We looked at the strength of their business plan, the scalability of the solution, and the durability of the pathway and permanent risks. Ultimately, we chose Aquarry because they hit the mark on each of the criteria that we judged projects on, and believe that REN's philanthropic funding can help them implement a solution that really elegantly integrates into the mining sector and ultimately has the potential to remove millions of tons of carbon dioxide from the atmosphere while simultaneously remediating toxic legacy sites. And we know CDR is important for global climate goals. We've set some internal targets within the industry of removing 10 gigatons. Is it 10? I think it's 10 gigatons by 2050 to meet Paris Agreement targets. And we think Aquarry is going to be a critical player in achieving those goals. So today I'm pleased to moderate this panel of industry experts and dive deep into Aquarry, how their technology works, how their work will benefit local communities, how credible monitoring, reporting, and verification can be designed and implemented, and then also explore the larger policy context for mine tech-based CDR. The aim of this session is to be conversational, so we welcome questions from the audience throughout, so please add any questions that you have to the chat. We'll also have some time at the end for any audience questions that come up. And then we'll wrap things up with a call to action. So currently, the REN Climate Collective has raised over $96,000 for Aquarry. We set ourselves a $100,000 goal initially, but because of the success of our fundraiser so far, we've increased that goal to $150,000. And so we'll talk about where that money is going to be going to and how you can donate to support their work. And at some point in this session, we'll have a QR code up for the fundraiser, so you can go check out how to donate. There's many different methods that you're able to make a contribution, and we can also put that link in the chat for those who'd like to donate. So without further ado, I'm so pleased for the number of speakers that are here with us today from different realms of the mine industry CDR sector. So I'd love to start with each of our speakers introducing themselves. If you could talk about who you are, where you sit in the CDR space, and how you're championing land-based CDR. And I will start with Dr. Kate Murphy.
Hi, everyone. Good morning or good afternoon, depending on where in the world you are. I'm Kate Murphy. I'm founder and CEO of Aquarry. We are a technology developer. You'll hear a lot more about that in over the next hour, uh, working to turn mines into carbon sinks.
Great. And we'll just go to Trina next.
Hi, my name is Trina Barrett. I am the co-founder of BAIE Minerals, and Baie Verte is my hometown. This mine site means a lot to me, my community. I have a very long history with this mine site. My father was the foreman of this mine site when the operation first started, and my family actually lived on this mine site for a number of years. And right now, this mine site is orphaned and abandoned, and my community is stuck with this huge liability with dealing with this problem. Mine companies came in and they took all the profits and they left us with this problem to deal with. So it's a classic case of environmental injustice. And so since 2019, we started developing processes and technologies with third-party institutions to address this problem and for my community. And what we notice, what we realize is that this is a highly alkaline, which is greatly sought after, and we realized that it's really sought after in the decarbonized mineral markets and the carbon credit market. So I'm looking forward to this discussion. Thank you.
Great. And then Mike, I'll turn it to you next.
Thank you. My name is Mike Sullivan. I'm one of the co-founders of BAIE Minerals. My background has been in resource extraction and waste management. So I'm part of a team working with Trina Barrett and developing technologies to transform the mine waste into decarbonized minerals and more recently in carbon credits. And our process is primarily focused on valorizing the mine waste and using it in waste to value technologies. So where others see waste, we see valuable resources, we see solutions and business opportunities. But as a project developer, this mine site has got extremely attractive. It's got all the attributes that make it a significant sustainable resource. So it's got scale. It's very, very large. It's got a high concentration of alkaline minerals. It's got a low cost structure. It's got existing infrastructure, and it's a brownfield, so it has a very short permitting cycle to get things done. So this makes the project bankable and economically feasible. It's an exciting opportunity at scale. We're excited to work with some of the CDR and carbon technology providers like Kate. Thank you.
Awesome. Thank you. I'll turn it over to Dr. Reese Savage.
Thanks, Sophie. My name's Reese Savage. I'm the mining carbon removal lead here at Isometric. We're a carbon registry aiming to solve the problem of a non-functioning carbon market. We help buyers by establishing trust with high-quality carbon credits, which are backed by clear monitoring, reporting, and verification protocols. At Isometric, we strive for scientific rigor and transparency in the credits that we issue. And we develop protocols for processes for mining-specific processes as well as other pathways more broadly in CDR. My background, I'm a mining geochemist. I've worked in the mining industry for the last 8 years, working with major mining operators to both develop carbon removal processes for mining-based approaches, but also to help develop protocols and methodologies to specifically quantify and verify those processes to sort of build trust in mining-based approaches for CDR.
Awesome. Thank you. And then last but not least, Eli Kane.
Yeah, thanks so much for having me, Sophie. I'm Eli. I lead policy development for the Carbon Removal Alliance. Before joining CRA, I spent most of the last administration working in the national lab system here in the US, where I led a $115 million carbon removal funding portfolio in collaboration with the Department of Energy. The Carbon Removal Alliance is the industry and trade association for the carbon removal field in the US. We represent about 30 carbon removal companies across the country in every technology pathway, and our mission is to act as the industry voice in the policymaking process, working with our members to translate their needs into effective program and policy design. We represent several companies who are doing mine-based carbon removal, including Travertine, who just opened up their pilot facility up in New York, and ARCA, who's doing work up in Canada as well. We've also been actively developing policy to incentivize the deployment of mine-based CDR in the US. We published a report on this topic earlier this year, and we have several policy priorities related to this work for 2026. I'm really excited to talk with the other panelists.
Awesome. Thank you, everybody, for joining. I'm just so thrilled to have such a breadth of experience and knowledge in this sector and excited to dive in. And actually, Eli, I'd love to start with you. If you could just really help us frame this conversation. Could you give us an overview of mine-based CDR and what policy developments in the space you're particularly optimistic about?
Yeah, absolutely. So there are many ways, as Kate and Reese will talk about, that carbon removal companies can integrate with mining operations, but predominantly they work with the industrial byproducts of the mining process. So in the United States alone, it's estimated that mining and the processing of mineral ores generates roughly 1.8 billion tons of mineral processing waste each year. Carbon removal companies work with this byproduct to reduce waste management costs, improve process efficiencies, lower environmental liabilities, and even do mineral recovery of critical minerals like nickel, cobalt, or phosphorus. And while they do that, they permanently, safely, and measurably remove carbon dioxide from the atmosphere. So today, these activities are predominantly occurring in Australia and Canada, but there are many based companies such as Aquarry who are trying to do this work as well. In terms of policy development, our work really focuses on one central thesis, which is unlocking more pilot and demonstration projects on mine sites in the US. So as the other panelists will attest to, mining is a really risk-averse industry. As the saying goes, everyone wants to be second, but no one really wants to go first. So we can utilize policy to incentivize first-time pilots and demonstrations that allow the mine-based carbon removal companies to demonstrate their value to their partners. This enables larger scale deployments, which unlocks demand in a nice virtuous cycle. And I will say, one of the reasons we're really excited about this space, other than the incredible companies who are doing this work, and I've had the chance to visit Kate's lab, they do amazing work, but it's also the true bipartisan nature of this issue. It really is one of the rare topics that's truly popular across the political spectrum. For example, a recent poll by Data for Progress found that roughly 67% of voters support more federal government activity in this space. So it really comes down to the tangible benefits that carbon removal companies bring to their mining partners and the bipartisan popularity of this work. So we're really confident we can make significant policy progress in the United States this year to catalyze these type of pilots and deployments.
Awesome. Thank you for that context. Yeah, I think those are similarly some of the reasons why Ren is excited about this work. But now I'd love to turn to Kate. So as the recipient of our grantee, could you walk us through your process for transforming mine lakes into carbon sinks?
Yeah, well, first let me tell you guys what a mine lake is.
Yes.
So these are effectively man-made water bodies that form in open pit mines. When you're digging a mine, whether it's open pit or underground, you almost inevitably hit the groundwater table. And what that means is that while the mine is operating, they have to pump all that water out. And then when the mine closes, typically those pumps get shut off, water flows into the pit, and you end up with this big man-made lake. But these don't behave really like normal natural lakes. They have very steep sidewalls, so you don't necessarily want to go swimming in them because there's no beach. You can't get out. Sometimes you can have very bad water quality, but really it ranges, pretty broadly. So what Aquarry does is we look for sites where there are alkaline minerals nearby. And what I mean by alkaline minerals is they have high contents of calcium oxides or magnesium oxides or hydroxides. Often these are available as finely ground mine tailings right on the site. Sometimes they're available nearby. You can see in some of the photos in the backgrounds of Mike and Trina and my videos, giant piles of finely ground, highly alkaline waste rock. So we do some work to get these waste rocks to dissolve using the pit lake water. We do some pre-treatments, we put them in a wet mill. Everything is done wet, which is crucial for this asbestos mine. You really don't want to generate dust, but it would be a wet process regardless. So we work to get these minerals to dissolve, which liberates more calcium or magnesium into the water. And that in turn makes the water a better absorber of CO2. So for those of you in the audience who are familiar with ocean alkalinity enhancement, it's very much similar to that concept. You increase the pH of water and it will absorb more CO2 from the atmosphere. So for us, we're working within these relatively contained systems. So as we add more and more calcium and magnesium, and we absorb more and more CO2, ultimately we will end up forming what's known as a carbonate mineral. So similar to a limestone or a chalk. These minerals will then sink to the bottom of the pit, filling the pit back in over time with a highly carbonaceous sediment. So that gets us a couple of things. Number one, it gets us a lot of CO2 capacity because these mines are really huge. The mine at Baie Verte can store approximately 40 to 50 million tons of CO2 in the water, and that's a relatively conservative estimate. It backfills the pit, which is a benefit in and of itself because typically these pits do not get filled back in. They are just left as holes in the ground. It's very, very expensive to fill a mine pit back in otherwise. And number three, it will often help to improve water quality. So as we're forming these carbonate minerals, they will tend to pull certain dissolved metals out of the water, like selenium, storing it away, locking it up so that it can't damage wildlife. Measurement and verification are then fairly straightforward for us because we are in a nominally closed system. We just take a sample from the lakebed sediment, measure it in a lab using very conventional means, and we can get a fairly accurate estimate or measurement of how much carbon is actually stored in the pit. So we work with mining companies or with sites that are on public land, like the site at Baie Verte, to turn these mines into carbon sinks, which is a process that lasts, probably decades in order to fully fill a pit.
Awesome. Thank you for that. It's so interesting to learn more about how these approaches work. And I think just the size of the tailings, which you can see really well behind Mike right now, is really just staggering, and love to see how these solutions kind of can provide dual benefits. In terms of the MRV, Reese, I'd love for you to just give us a little more insight into how it works, what differentiates Aquarry's approach from other mine-based CDR pathways, and yeah, just give us a little bit more color on how you're thinking through that.
Yeah, I think it's important to take a sort of broader step back to sort of explain why MRV and transparent MRV is really important, specifically for mining-based approaches. So MRV itself is an important step for building trust in carbon removal. Ultimately, from a mining operator's perspective, they want to make sure that what's happening on their mine site is actually real and quantifiable, and essentially doesn't qualify as greenwashing, which I know is a big concern for a lot of mining operators. Decarbonization is a big topic in the mining industry right now, and being able to quantify a net removal is an important step for a mining operator, and that needs to be done by an independent third party, which is essentially what registries like Isometric are set up to do. MRV typically works in a way that a registry or body like Isometric will produce a protocol for a process like Aquarry's. These are usually pathway level protocols for things like ocean alkalinity enhancement, open system ex situ mineralization, or enhanced rock weathering, for example. Those can then be used to quantify removals from a process that removes carbon from the atmosphere, and that can then be checked and validated by an independent validation and verification body, a VVB, before we then issue credit. The importance for that, for mining CDR, like I said, is transparency. Like Eli mentioned already, no one likes to be first. So providing that level of rigor and scientific integrity is really important for both the mining operators that are allowing CDR suppliers onto their sites, but also for the buyers that are buying those credits. MRV for mining, this particular aspects that need to be considered over other pathways, things like mine closure, waste management, environmental integrity. These things are more prevalent for mining-based CDR. And the importance of developing specific MRV for these type of processes is even more important because you need to be able to both fit within mining regulation and mining the sort of day-to-day processes while also being able to rigorously quantify the carbon that's removed. For Aquarry, I think it's an interesting process when I consider it in the broader spectrum of CDR. Realistically, the use of ambient sort of ambient low energy processes is particularly, I think, useful towards larger scale scalability for these type of approaches, which is particularly important for mining-based CDR. You need to have a process that can scale and scale big. Like we were just talking about the scale of the pile behind Mike. Realistically, Baie Verte is a large process, is a large site, and there's a lot of potential feedstocks there. But that scales globally. There's sites just like Baie Verte or on the scale of Baie Verte with different feedstocks across the world. And realistically, we need to scale large. So having processes like Aquarry, which, the quantifiable MRV can be quite straightforward because of the closed system or semi-closed sort of nature of pit lakes, means that, these type of processes can be quantified and are sort of like achievable with a considerate MRV protocol.
Awesome. Thank you so much. Yeah, sometimes MRV can be this like really nuanced topic with lots of different criteria and things to wade through. And I know certainly as a buyer of CDR credits, it can be difficult to navigate that process and understand how it works. So thank you for providing some more light on that. I'd love now to just talk about kind of the local context. So Trina and Mike, you are, close to the proposed pilot site for Aquarry. Could you talk a little bit more about what the local response has been in Baie Verte so far and how this project will create tangible benefits for the surrounding community?
So I work closely with the community and community leaders in Baie Verte. And at one time, this site employed 550 people, and it was a big economic driver for Baie Verte. And once the mining company left a big economic decline for Baie Verte, and resulting in a lot of tax revenue loss and job losses. So now the community they're open now to a reclamation, creating jobs, and basically to clean up the site, but do it safely. The feedback I get a lot from is that we get endorsed a lot because our process is wet. If you're not familiar with asbestos is it's a respiratory toxicity that's only a hazard if it's airborne. So if you keep it wet, you're safe. And that gives us a social license. That's part of our social license to proceed, is that it is wet. And what we really like about Kate's process and methodology is that it's wet. And actually, I want to share something, if you don't mind. I want to share something with Kate. Kate, this is for you, because I posted that we were working with you in our community. And I get a lot of comments, and I want to read one comment that stood out, and I want you to hear this. So please just give me a second here. Okay, so this is the kind of information, this is what I get. I just read amazing news about your new venture, and I had to comment. I am beyond proud of you and the incredible work you are doing. It takes vision and fortitude to tackle such a huge environmental problem, especially in a place that means so much to many of us. You are turning a legacy of negative health impacts into a positive solution, and that's nothing short of heroic. So, Kate, thank you, because that means a lot to my community. They love seeing this wet process and that you're helping solve a problem, and it's much needed. So I just want you to know that. So it means a lot. So thank you.
Thank
So I
you.
just want to say also that, this is important to the community. It brings new life to a dead mine. I mean, this is an end of life mine. It's been dormant, it's been dead, and it's an easy story to tell to the community. And because the community is getting excited about it because of the potential, not only in extracting minerals, but also a carbon solution. And one of the value proposition here is that the mine waste has the potential to create more value than the original mine.
Yes, thank you guys for sharing that, Trina. That comment like gave me chills, like nearly brought me to tears. I think CDR again can feel kind of nebulous, and like when I'm a buyer of credits, like I'm trading air. Sometimes it feels like how is this tangible? What can I hold in my hand? And hearing that feedback from the community is part of the reason Ren really values this work, and are really proud to partner with folks like Kate. So thank you for sharing that. I'd now love to open it up to kind of a broader conversation and have all of the panelists chime in as you feel compelled. I'm curious from your perspective, what barriers exist today for deploying CDR technologies like Aquarry at mine sites?
Yeah, I can take that one. So, as Eli or Reese mentioned earlier, in the mining industry, everyone wants to be first to be second. And so having a demonstration site with committed partners has just been, it will be a major unlock for us. The mining industry has made tremendous strides in the past decades in safety, both for humans and for the environment. A site like Baie Verte would not end up the way it is in the modern era. Mining companies are much more responsible now for their abandoned mines or for their closed mine sites, not abandoned. And so because they've made such tremendous strides, there's a real hesitance to take on risk, and any new innovation is seen as risk. And so with this project, we expect that we'll really be able to demonstrate to the mining industry on the whole a couple of things. One, that the process works, of course, but also that it is safe, that it improves water quality, that it can be profitable, that communities will appreciate the cleanup work and the carbon removal work that we're going to be doing. And so we expect that this will be a major unlock for us. We do get a lot of interest from mining companies that have these sites and don't really know what else to do with them. But there is this hesitance because we haven't demonstrated it in the field yet. And so that has been perhaps the major barrier. And Trina and Mike have done such an incredible job with turning Baie Verte, the mine site of Baie Verte, into a hub for technology developers that it's going to be a major unlock for us, as well as, I believe, for many other technologies that are in the pipeline for mining CDR and mining waste reuse.
I think one of the things I'd echo there, just based off what Kate was saying about mining companies being cautious, is what I'd say. And I think part of that as well is when I'm trying to describe to people the complications with both operating a mine and closing a mine, it's when an operator sets up a mine, they often have a life of mine which stretches over, it could be 30 years, it could be 50 years. They typically have to have a permit in place where, mine closure has to be considered. There's a closure plan. Setting up those closure plans and having that sort of like run of mine is quite an expensive process. So one of the things here is sort of like outlaying how these processes fit into closure plans. Can they be updated as part of permits? How does a mining operator go around actually implementing these processes? And I think it's why it's particularly important for CDR processes in mining sort of like locations. They need to consider, how do we fit into waste management? How can we become part of processing? How do we fit in to waste storage? And I think that's one of the key things that suppliers have to look at. And I know Kate's thought about this a lot. You know, there's nothing better for me, you know, as someone who worked in mine waste management for a number of years. Storing waste on site in previous excavations is a key thing for sort of making sure that waste stays on site. So I think that's a key thing that will attract mining operators. But again, when we're talking about roadblocks, the big thing is, okay, if we already have a process in place, how does this improve our process? How can this fit into our process?
And we've been very deliberate about trying to mimic and integrate well with mining reclamation processes as much as possible. So our process doesn't look all that different from a typical, when you have an acid mine, alkalinity dosing for an acid mine. We, as much as possible, try to use conventional mining equipment, you know, conveyors and wet mills and things that the mining industry is familiar with, that they have the expertise with, that they have the workforce to run. We're trying to make this as close to a conventional mining process as possible, which will speed development, speed deployment.
Yeah, I would maybe just say, you know, what Kate and Reese just mentioned is exactly why we believe policy plays a huge role in unlocking these deployments.
Yeah.
Because mining is an incredibly heavily regulated industry, right? Every step of the process is regulated, from permitting to requirements to bonds, and mining CDR companies need to work within that broader regulatory framework. And policy can make that easier, or it can make it harder. And today it makes it harder. And we really believe that like some subtle tweaks to the regulatory framework will make that easier. And maybe it's like in the United States, especially, mining policy is really focused on like carrots, not sticks, when it comes to regulation. For a few reasons, like we don't really love to impose too many sticks on the mining industry, but also the mining industry is a low margin, internationally traded commodity. And so if we impose more stricter requirements, we're just driving mining to less regulated markets. But if we can impose carrots and make it easier for people to deploy, we can de-risk these technologies for the mining partners. We can do technical assessments and small scale pilots. We can make permitting easier. We can reduce liability concerns for mining companies. All of these are areas where policy, I think, plays a really pivotal role here, in addition to like really forward-thinking partners like the BAIE Mineral folks.
Awesome. Thank you guys for sharing that. I do have a few questions in the chat that I want to touch on because we're talking about kind of the science aspects of this. There's a question, can you talk about the chemistry of how you solubilize the alkaline minerals?
How we get them to dissolve.
Yeah, I think
Yeah,
that's the
so some of that is a little bit secret sauce, but we apply some pre-treatments to these minerals, add them to our wet mill, which is basically an attritor, and that will kind of rub off the surface of the minerals so that we can accelerate that dissolution. Final particle size ends up being quite small with these conventionally with these wet mills. You're grinding down to 20-30 microns. So particle size, pre-treatments, those are the ways that we're getting these materials to dissolve. Certainly, they're not going to dissolve as quickly as I think I saw in the chat. You know, the kind of lime that people are using in acid pit lakes. We don't see that in our beaker tests that you know at the scale that we've been working at, but it may be an issue when we apply these materials to the lake. However, it's important to note that we're driving the dissolution outside of the lake rather than just passively letting the materials dissolve in the lake.
Awesome, thank you. I would love to turn to a kind of a conversation now on partnerships. So, you know, there's 3 different organizations, 4 including Ren on this call, brokering partnerships in different ways. And a question for all of the panelists, what do you think is needed to broker strong partnerships, and why are partnerships important for this work?
Yeah, I think
Well, Do you want to go?
Well,
Collaboration is a big thing. I mean, one, the community has to be at the table as a partner. And that way you get your social license, you get your buy-in, and the trust building. So one is the community, and the other partner you have to have is the regulators. You know, they have to know that, this is a pathway to creating a value proposition for waste, but it's also done safely, and the rules can be rewritten. This is brownfield, and so you don't have all the high bar regulations that you would have with a normal. You're not cutting trees down, you're not making an environmental disturbance. It's progressive reclamation, and you're cleaning it up. So from our perspective, you got science, but also you have administration and community and regulators, and the partnership is basically working together and pulling in the same direction.
Another thing I like to add to Mike is that all this came from the pits. It can go back in. It's the ultimate reclamation. It's too expensive to do it any other way, but Kate has a value proposition that makes it possible. So that's the other advantage here. And yeah, I mean,
Sorry,
I would.
Reese, I interrupted you.
It's all good. I was just going to say, I think the key thing with partnerships here is trying to reconcile the fact where mining and CDR are two very different industries. And I think we're trying to pull two very different things together here, which I think is something that is really important for building partnerships and scaling to potentially megaton, gigaton scale. I often talk to a number of CDR suppliers where I try and explain you need to make partnerships with companies that are working on decadal processes. Realistically, they're planning out 20, 30, 40 years in advance, whereas CDR companies are often thinking about the next 6 months. So I think that's one of the key thing with partnerships here is you're trying to make sure that that's what the importance of needing to fit into a process, be streamlined, have a clear set of, okay, this is how we're going to quantify this. This is our end product. This is our value proposition. Because realistically, a mining company needs to know that if it's going to be worth it for a mining operator to fit you into a process that is already well set out.
Absolutely, yeah. I oftentimes think about collaboration as opposed to competition in this space, and the CDR industry is so small that it feels like a more collaborative space than perhaps other markets do. And I think that it feels like there's a lot of like information sharing and like championing each other in this space, which I really appreciate. Like, even, you might have two CDR suppliers or developers working on similar processes, but perhaps they're both working with isometric in similar ways or both working with CRA in similar ways. And so it's like, what is the tide that can lift all ships, or whatever that saying is. And I think that that's like a really powerful thing in the industry. But of course, with like mining or with other complex sectors, it takes time. I had a professor in grad school who told me policy works on policy timescales and ecosystems work on ecosystems timescales, and they don't all that often mesh. And so trying to kind of reduce that tension between the different priorities of different actors, I think is critical for this work.
There's more than enough carbon to go around.
Exactly. It's like, yes, and that's kind of my answer to most things is yes, and like removals and avoidance, like nature-based and engineered. Like there's, we need to be approaching this problem from every angle possible.
Yeah, I think the thing I'd say there is this is an industrial scale opportunity that needs industrial scale application. So for mineralization, OAE, enhanced weathering, whatever it is, we need industrial scale CDR to really make a difference. And mining-based approaches are inherently industrial scale.
Absolutely. I want to take another question from the chat right now. This is a question for Kate. How are you working to prove that this model will work at commercial scale?
Do they mean the business model or the?
I think
technology model?
maybe the technology model, I think.
Okay. Yeah. So what's nice about mines is they're really big. And so, as I mentioned earlier, Baie Verte in these two pit lakes has space for 40 to 50 million tons of CO2 if we're using the asbestos as our feedstock. And so that's a nice business just on its own. In order to really scale and get commercial, our plan is to work directly with the mining companies that are already spending money on these pit lakes, who are already managing the pit lakes, and who are also spending money on decarbonization. So that includes pretty much every major mining company. Every major mining company has made billions of dollars of investment on decarbonization and has plans to make additional billions of dollars in investment on decarbonization. And that's generally a cost for them. And so, our business model is really to be a technology developer that we can hand things, we can help mining companies and hand things off to them. As far as getting the technology to work, the low-hanging fruit for us is alkaline pit lakes, or pit lakes with alkaline feedstocks nearby or on site. We have mapped out about 20,000 pit lakes globally just using machine learning, image recognition on satellite imagery. So there are a lot of target sites. Mapping out which ones have feedstocks on site is a bit more tricky. It's something that we're working on, but that does take some money. And so we don't see any reason that the process wouldn't work in other mine sites. So, it will certainly work in other asbestos mine sites, and it will also work in other sites where you have alkaline minerals on site. So things like diamond mines, certain nickel mines, certain iron mines. And so, as we mentioned earlier, we're trying to use conventional mining industry equipment so that we're not terribly beholden to a single type of feedstock. Our process is very mechanical, meaning that it can translate from feedstock to feedstock. I think that answers the question, but I'm happy to take follow on.
Yeah, that I think that's good. And it's a nice transition into another question I have for you, Kate. And definitely, if other panelists have insight into the role of philanthropy in CDR, please chime in as well. But specifically for Kate, how will REN's funding be used to scale your operations, and why is this funding important for you? And then maybe for our other panelists, like, what do you see as the role of philanthropy in the CDR sector currently?
Yeah, so it's no secret that we're based in Colorado. It's no secret that a lot of federal funding for CDR, or really for anything in climate, has been cut. And so for the stage that we're at, we should be able to bring in a lot of federal funding. And so this grant is really filling a major gap in funding for us. So what we plan to do with these funds is, continue to build out our, it's effectively an indoor pilot or prototype. We're using a cattle watering trough as our pit lake. But that really just means it's a 1,000-liter tank that looks an awful lot like a pit lake. We will be able to make some hires, extra technicians. We need more hands to run their experiments, to string all of our unit operations together, and to optimize them. That will set us up really nicely for an on-site pilot at Baie Verte, which will enable us to bring in additional funding, both from private sources as well as the Canadian government, because we're very fortunate to have Canadian partners. And it will effectively, as I said, fill this gap that is now missing for a lot of climate tech companies within the US.
Awesome, thank you.
I might just piggyback on that really quickly, and taking the question in a slightly broader context, and say it's my job to restart that federal funding engine. In the meantime, there is a huge need for what I would call the creative capital avenues for carbon removal, and REN plays an incredibly important role in that. It's not an easy time to raise venture capital money, nor is carbon removal always that well situated for the VC model. And so avenues like REN really support companies in making that initial step to commercialization and actually becoming profitable. while we're working in the background on the policy side. I mean, Sophie, you mentioned it, policy works on long timelines, but companies need near-term acute support. And so I think that is the role of creative capital in today's ecosystem, for better and for worse, right?
Yes,
You know,
that's exactly our theory. Go ahead.
we see philanthropic capital and also impact investing as critical to reducing the cost of capital, and also, you know, de-risking, you know, and we view a lot of these models as for purpose, but also for profit. And, you know, so you have the for purpose money coming in, but you can make a lot, you know, there's a profit element to this, that there's a high value proposition. It just happens to have a strong for purpose agenda.
Yes, yeah, I think that kind of is more or less our theory of change, is like these companies need money now. Let's get them to the point where they can get to commercialization while also working on all these other angles, the MRV, the policy, the partnerships.
I'd
I
add
think
that there's also something sorry.
go on, Kate.
I'd add that there's also something special about Ren's model with these, you know, small dollar donations. From the standpoint of, it shows that there is broad interest in this. I don't know the numbers of how many donations we've had, but there have been quite a lot in the, you know, $10, $20, $50 range. That means a lot to me and my team, just emotionally, but also it's serious social proof that what we're doing is valuable. So much so that people are willing to give up their hard-earned money to see us succeed. And that is kind of new. That's not something that we've seen in other philanthropic, you know, the other philanthropic sources that we've been able to tap. So really kudos to Ren for running these crowdfunding campaigns. I mean, they're so meaningful in so many ways.
Thank you.
Sorry, go ahead, Reese.
I think the last thing I'd add there is I think it's hard to sort of state the importance of this type of funding at this stage for different technologies too. Everyone likes to talk about large offtakes. You see the large buyers in the space, but ultimately, in order to attract large buyers in this space or broader sort of appeal across the market, you need to be able to see scalability and trials. In order to build trials, you need this early stage funding. And it doesn't need to be, you know, XYZ amount. It just needs to be enough for companies, you know, like Aquarry to build those initial pilots and show commercial demonstration and get through that TRL valley of death realistically. And I think that's what, you know, funding like this realistically is going to provide.
Yes, thank you. I'm going to have my colleague share a screen with the link so you can go to donate. And just to Kate's point about these small dollar donations, we've had 122 individuals support Aquarry's work. And
Incredible.
broadly speaking, from Ren, we've raised over, I think, 20 million for climate solutions so far. And I think that just really shows the power of collective action. And I think that a lot of individuals maybe feel like they don't have a role or they can't make an impact. But I think what Ren has been able to demonstrate really clearly is when people get together, we really can make really major impact. Where, you know, we've done, I think at one point we were in like the top 10 of CDR buyers in the world. We've been bumped down that list, which is a great thing to see other people playing. But it just really shows that, like, you know, when individuals act collectively, we can make a really big difference. So these links on the screen will bring you to the fundraiser page for Aquarry, and you can make a donation of any size, and through multiple different methods. You can do DAF, stock, multiple different methods. And if you have any questions about how to donate or how your money will be used, please feel free to reach out, schedule a meeting with myself or Ben, and we can kind of walk you through that process. And as I mentioned, we've increased our goal from $100,000 to $150,000 just because of how successful this campaign has been. I think in part because of the strength of Aquarry's process and how exciting it is and how real it is and the community impacts that Trina and Mike talked about. I think that it's just one of my, not to play favorites, but it is one of the most exciting projects that I've come across to date. And I personally gave money just because I was so excited about the process. So those links will be up on the screen. In the meantime, we do have quite a few audience questions. We'll try to get through as many of these in the last 10 minutes. Let me see, where can I start? Maybe a question that I can answer. I see that I can donate personally to Aquarry on Ren's website. How do philanthropic donations fit within other forms of funding like debt or venture for Aquarry and other carbon removal projects? I think we might have answered that a little bit in the previous conversation. But of course, all types of financing are important for these companies. But as we kind of mentioned, the philanthropic funding really helps get over that valley of death and really helps a company become more bankable at the end stage, which is kind of our goal. We kind of think about it at Ren as a pipeline. And so ultimately we want to fund these projects with philanthropic dollars, get them to the point where they can then start to sign commercial agreements for offtakes or pre-purchases, and then ultimately channel them back into our Trailblazer portfolio, which is focused on purchasing, pre-purchasing CDR. And we pair each pre-purchase credit with a super pollutant avoidance credit so you can offset today. And then ultimately, once they're delivering, we'll channel them into our classic portfolio so that individuals can eventually offset with the credits from Aquarry. So that's kind of our theory of how that pipeline works. Let's see, another one from Mike. How long-term a carbon sink can a pit lake be? Could the carbon get released in the future if the supply of alkaline material is stopped? And I'll let anyone who has insight answer that.
No. So we do not work in sites that are going to be continuously acid generating. So the way that carbon could be re-released is if you either heat it up to 900 degrees C, which means we've cooked the planet, or if you dump acid on it. We do not work in sites that you have a lot of acid generation. I think Mike asked a question earlier about neutralization of acid pit lakes. Yes, there are many acid pit lakes in the world. We just don't work in those sites because there is that risk of re-release. So as far as timeline goes, the process is, tunable based on, how quickly you're adding material, how much aeration you're doing. We generally look to have projects running for 10 years for a very small site, up to 40 years for a larger site like Baie Verte. This is really to maximize the use of any capital equipment that we need to install. If you can imagine, a mill might have a lifetime of 30 or 40 years, so you would want to maximize that utilization. All of these things are tunable. It will not be a carbon sink in perpetuity. At some point, you will have filled up the pit. And at that point, you can leave it with a little bit of water on top and it looks like a natural lake, or you can, just cover it with dirt and rock and try to restore the landscape. So these are permanent storage sites, but they're not long-term capture sites, or long-term meaning more than 40 years.
Awesome, thank you. And we have another question, maybe Trina and Mike might be able to answer this one. Are there regulatory or permitting aspects that are challenging for implementation of this pathway?
So a lot of it, because it's a brownfield site, the environmental registration is very, very short-circuited because I think I mentioned earlier, it's already environmentally disturbed. So the impact statement is basically community. If the community objects to the project, you're going to have a challenge. If the community's on board and supports it, you're going to have a quick path, to regulatory approval. It's a dead site. It's a orphan abandoned mine site. So the permitting is relatively easy.
Maybe I'll just quickly add on from the US context. Yeah, a lot of regulatory hurdles here in the US for this. And they really come down to maybe two big buckets. One is permitting concerns, and the second is liability concerns. And so those are really the two areas that we can kind of help to ease the permitting cycle. So yeah, big challenges, and that's a lot of what our work here at Carbon Removal Alliance is aiming to address.
So,
Yeah, from a permitting standpoint. Sorry.
I keep cutting you off, Kate.
I keep cutting you off. I'm sorry. You go first this time.
I was just going to say, from a broader regulatory perspective as well, I think it's important to split this down into what we consider as like permits and what is waste regulation, etc. Because there's different considerations here. So, for example, it may be quite easy to get a permit to do a process, but then you have to consider, okay, well, what's the waste management process that is in place? What's the regulation for the waste material? And that's going to vary greatly depending on geography as well. So something that may work in Canada may not work necessarily in Europe. So I think that's the other consideration here is like there will be permitting challenges for any pathway, but the same as any other pathway, that's going to vary massively by geography, waste type, site type.
Yeah.
Just to put a fine point on that, much of the mining permitting in the US is governed by the Mining Permitting Act of 1872. 1872, right? Like these are incredibly antiquated and outdated permitting requirements that companies with novel technologies are trying to fit within. So a lot of work to be done.
So specifically for our process, when we have talked to regulators, their concern is, what are you doing to our water quality? Because often these pit lakes are in communication with groundwater. And are you going to be creating any dust? So we've designed our process so that we can show that even if we're using slightly contaminated feedstocks, for instance, steel slag, we can remove those contaminants of concern and not damage water quality. Several mining companies have also told us, yeah, we think this will fit within our existing, water treatment permits. Again, because this looks an awful lot like traditional acid neutralization processes. Of course, these aren't acid lakes, but the process doesn't look all that different from a conventional acid neutralization process. So yes, there are policy changes needed globally to speed things up, but we can design our process so that we can fit within existing permits as much as possible, or permitting structures rather.
Awesome, thank you. I have another question. It's multi-parted, so bear with me. The question is, can you quantify the amount of CO2 that can be stored in an easy to understand way? For example, how many tons of CO2 could be stored in a single lake? What is the price outlook for these credits, and where would you like to see them? So take that as you. Great question.
Yes. So the easy to understand way is you have a volume and you have a certain density of CO2 or carbon that you can fit within that volume. And the volume being the volume of the water. And so the pits at Baie Verte are approximately 200 million cubic meters of water, 200 billion liters. Someone will have to convert that into gallons for me. 50 billion gallons, roughly. And we can calculate with pretty good precision, what the density of the sediment is and then what the density of the carbon is. So it's a fairly straightforward density times volume calculation. And then the other question was about the price outlook. Yeah, so this process can be extraordinarily cheap because we're not moving materials, we're not having to buy our feedstocks. So really the big expenses are, CapEx for, things like wet mills and conveyors, and then electricity to run those processes. So what's really nice about the Baie Verte site is those tailings are 0.2% nickel. There's about 600,000 tons of nickel on that site. So some of that cost can be offset by the sales of nickel because we would be removing nickel anyway. We're not discharging nickel into the pit. All that is to say, at scale without metal sales, we're looking at under $130 per ton. With metal sales, we're looking at under $70 per ton. We will sell any credits at market prices.
Awesome. Well, thank you all so much. And unfortunately, we have like a very lively Q&A box, and I'm sorry if we did not get to answer your questions. Feel free to email me and I can pass those questions on to Kate, or we can have a longer discussion. Perhaps we should have scheduled this webinar to be an hour and a half, because there's truly just so many different aspects of this work to discuss, both from the MRV perspective, the local partnership perspective, the developer perspective, the policy perspective. There's a lot of different folks coming together to solve this challenge and ultimately scale carbon removal. And I know Ren is just really grateful for the work of Isometric and BAIE and Aquarry and CRA. It takes, many, many hands to make this work happen. So thank you all so much to our panelists for joining us today. Really appreciate the insight that you could provide. And thank you everybody for joining our webinar today. Please reach out if you have any questions, and we will wrap up there. I think we are at time unless anyone has final remarks.
Just want to say thank you to the whole team at Ren, particularly Sophie and Path, for putting on this fantastic webinar.
Thank you.
Thank
Thank
you.
All
Thanks,
right.
everyone.
Bye, everyone. Thanks so much.
Bye-bye.